So today we will be talking about glycolysis, which is basically the first step in cellular respiration, as many of you may know. Glycolysis can have two fates depending on whether we have aerobic or anaerobic conditions. Aerobic meaning there's oxygen available, anaerobic meaning without oxygen. But I don't want to complicate anything for this video. This video is just a general overview of glycolysis, but let's get started. So glycolysis is the pathway in which we are breaking down glucose. So we are breaking down one glucose molecule, if I can spell glucose right, into two pyruvate molecules. So glucose is a 6-carbon molecule. Glucose is actually a hexose sugar, which just means that it's a 6-carbon sugar. Sugars, the ones that we eat. I really like glucose. I'm sure many of you do. But glucose is broken down into two pyruvate molecules. And a pyruvate is a 3-carbon molecule, which you will learn a lot about in the future videos, and I'm sure you've heard about. But for now, we will just leave it at that. So the overall purpose of glycolysis is to produce energy. And we essentially are making ATP. And we're making 2 net ATP. And you're going to ask, why net? So basically, glycolysis requires that we put in energy as well. But we also get energy out of glycolysis, and we end up getting more energy out than we put in, which gives us our 2 net ATP. We also make NADH as well. And so whenever you think of ATP, I want you to think of high energy molecule. And whenever you think of NADH, I want you to think of electron carrier. Because NADH will ultimately pass on its electrons to the electron transport chain, which is one of the last few steps of respiration. And that is how we can get out a lot of energy. And so back to glycolysis. Glycolysis is not just one simple reaction. I wish it was. It's actually 10 total reactions. And many of you know that reactions are often catalyzed by enzymes. So you would be correct to think that we have a total of 10 different enzymes. And this is where it can be a little difficult to learn glycolysis, because for some classes you may need to know the details of all the steps. You may need to know all the structures as well. But just know for an overview that it's 10 different enzymes, 10 reactions, and in future videos I will have mnemonics and easy ways to kind of remember those enzymes. So do stay tuned for those. And glycolysis, we said, was the breakdown of glucose, correct? But the opposite pathway of glycolysis is gluconeogenesis. And so gluconeogenesis is the production of glucose. And one important thing that you need to know about gluconeogenesis is that it is not simply the reverse of glycolysis. And that is such an important point that I'm going to capitalize it, is that it is not simply the reverse of glycolysis. It is the opposite pathway, but it will use some different enzymes because there are 3 irreversible steps in glycolysis. And irreversible meaning you can't go back the other way in gluconeogenesis, and so you will need different enzymes for those steps. Another thing that I wanted to mention about glycolysis is that you'll often hear it referred to as the oxidation of glucose. You may even hear the catabolism of glucose, and I would not want you to get confused. Both of these just simply mean we're breaking down glucose, we're getting energy from it. Another very important point is, where does glycolysis happen in our cells? So glycolysis happens in the cytosol. And this is different from where other reactions might happen, such as the electron transport chain and things like that. Glycolysis is simply in the cytosol. And another thing that I wanted to mention is that glycolysis can be broken down into 2 phases. And since we said that there were a total of 10 reactions, or 10 steps, each phase consists of 5 reactions. So the first 5 steps, the first phase, is called the energy investment phase. And essentially what the net reaction for this is that we're taking a glucose molecule and we're breaking it down into 2 GAP molecules. And GAP is just simply another intermediate in glycolysis. Don't get too confused. We will talk about GAP later on. But the important takeaway from this is that the energy investment phase caused 2 ATP. And remember, I told you before that we need to put in some energy to get more energy out. So this is where we put in that energy. The next phase, or the second phase, is called the energy recovery phase, where we take those 2 GAP molecules and we further convert those into 2 pyruvate molecules, which, remember, was the ultimate goal of glycolysis, to break down into 2 pyruvate molecules. And then that pyruvate can have different fates. If we are in aerobic conditions, then we can take that pyruvate through into the electron transport chain. And obviously it will not go directly. There is another reaction in between called the pyruvate dehydrogenase complex that it'll have to go through first. But essentially, if we are in aerobic conditions, the pyruvate will go through all those energy from that will go into the electron transport chain and we'll get a lot of energy. But if we're in anaerobic conditions, then that pyruvate could either end up as lactate, or if we're doing alcohol fermentation, it would have a different fate. And we'll talk about all that later. I just don't want you to get confused. But I did want to make an important point that pyruvate can have different fates depending on if we have aerobic conditions, which, remember, means with oxygen, or anaerobic conditions, which means without oxygen. And I think that is all I want to say for this video. Just to give you another summary of all that we said, glycolysis is the breakdown of glucose. And just a little tip for you, maybe in your future classes, it could help as well. The root lysis means breakdown, and the root genesis means making, synthesis. I meant to do that, yes. So lysis, glycolysis, is the breakdown of glucose. Gluconeogenesis is the synthesis or making glucose. And so that's very, very important to not mix these 2 processes up. This video is about glycolysis. We're breaking down that glucose. And you might ask, why are there 2 different pathways? And if these pathways are functional will largely depend on the needs of the organism, the needs of the cell at that time. If you think about it logically, and I do want to kind of incorporate bigger picture ideas into this because I think that it will help you in the future. If you have low energy, let's say you have low glucose levels, then you would want to do gluconeogenesis to make more glucose, remember? But if you have a lot of glucose, then you would do glycolysis to break down that glucose into energy. And just a quick summary before we go is, remember, glycolysis is breaking down glucose into 2 pyruvate molecules. We made a total of 2 net ATP. We also made some NADH. And remember, NADH will give those electrons somehow into the electron transport chain, which we will talk about later. There's a total of 10 reactions, 10 different enzymes, and there's 2 different phases of glycolysis: an energy investment phase and an energy recovery phase. But the big takeaway from this is that we're breaking down 1 glucose molecule into 2 molecules of pyruvate. And that is it for this video. I hope to do later videos on more details of glycolysis, all of the different 10 reactions, 10 enzymes. So stay tuned, and thanks guys. Good luck with all of your studies.